A bright red fish sits motionless on the ocean floor at 2,500 meters deep. It has not moved in hours. That stillness is a weapon. The creature is Chaunax pictus, the sea toad. Johann Jakob von Tschudi formally described it in 1854 from specimens pulled off Peru. It took another century before anyone saw one alive, in place, doing exactly what it does. What it does is nothing. Deliberately, precisely, nothing. Its pectoral fins are thick and limb-like, planted against the pale sediment the way a person might press their palms flat on a table. It does not swim. It sits. It waits. The only movement is a single filament above its snout, the illicium, swaying almost imperceptibly in water that barely moves. Pietsch and Orr published in Zootaxa in 2009 after the most comprehensive revision of the family Chaunacidae ever conducted. They described what sits at the end of that filament. The illicium is short and stout, bearing a terminal esker that in life is presumably luminescent, a built-in lure, millimeters from the mouth. Not above the body, the way most anglerfish carry theirs, right at the door. The body itself is covered in fine dermal spines, not scales. The skin is loose, distensible. Chaunax pictus can pump water into its stomach and inflate to nearly twice its resting size. A defense mechanism entirely separate from anything a pufferfish does. Different system, same result. But here is what stops every researcher who encounters the first good ROV footage. The color, vivid, saturated, stop, sign red. At 2,500 meters of depth, in near total darkness, this creature is the most conspicuous thing in any direction. That question has a specific, documented answer. It involves the physics of light, the absorption spectrum of seawater, and research published in Science in 2010 by Edith Widder of the Ocean Research and Conservation Association. By the end of this video, that answer will completely reframe what you just saw, what red actually looks like down there, and what it looks like to the animal about to die for approaching it. Here is the obvious explanation. Red animals in the deep sea are invisible. Textbooks say so. Case closed. Edith Widder, Ocean Research and Conservation Association, wrote it plainly in 2010. Red coloration at depth functions as effective camouflage because red wavelengths are absorbed within the first 15 meters of seawater. 15 meters. Red light dies before it reaches the continental shelf, let alone the sea floor. Deep sea shrimp are red, deep sea crabs are red. Dozens of species wear the same color for the same reason, not to be seen, but to disappear. The logic is airtight. No red light at depth means a red body reflects nothing. Black water, black animal, invisible. So Chaunax pictus is red for camouflage. Explain, filed, move on. Except the saturation does not match. Theodore Pietsch's 2009 taxonomic revision of the Chaunacidae documented the coloration in preserved specimens. The red is not faint, not muted. Not the dull brick red of a shrimp built for disappearing. It is vivid, saturated. The kind of color that stops people cold when they open a museum ichthyology drawer. Passive camouflage does not require that. A creature built to vanish needs just enough red to render it dark at depth, not more. The physics don't ask for brilliance, and yet brilliance is what the specimens show. Then there is the lure. Pietsch and Orr described it in Zootaxa 2020. The esker is, presumably luminescent, a pulsing biological signal broadcast into total darkness. Camouflage does not pulse. Camouflage does not advertise. And the inflation. When threatened, Chaunax pictus pumps water into its stomach and doubles in size, not smaller, larger. A creature, relying on invisibility, should freeze, flatten, disappear into substrate. This animal expands. It becomes harder to miss. 3 separate behaviors, 3 separate failures of the camouflage model. So if the red is not purely camouflage, if the saturation, the lure, and the inflation all point somewhere else, then what is the color actually doing? Here is the answer to the question this video was built around. Red light disappears at 10 meters of depth, not gradually, gone. The water column absorbs the wavelength entirely before it reaches the seafloor. Edith Widder, writing in Science in 2010, confirmed it. Red wavelengths are absorbed within the first 15 meters of seawater. Chaunax pictus lives at 2,500 meters. Do the math. At that depth, there is no red light to reflect. None. The vivid crimson body that startles every marine biologist who lifts a specimen under fluorescent light, that color does not exist at depth. It cannot. The physics will not allow it. The creature is not red down there. It is black. Every photon of ambient red light was swallowed by the ocean 2,485 meters above the sea floor. The sea toad settles into pale sediment and vanishes, not because it is camouflaged the way a chameleon is camouflaged, but because the color itself ceases to function. A depth-dependent invisibility cloak built from nothing but physics. But one part of this animal is designed to be seen. The esker, that small bioluminescent lure Pietsch documented in 2009, sits close to the mouth, just millimeters from the strike zone. It pulses. In a column of water where no other light source exists for hundreds of meters in any direction, a single point of cold blue-green light is an event. Something approaches. Something always approaches. The body remains perfectly, completely still, black against black. The lure sways. A small fish descends toward the only light it has ever seen. Grobecker's 1983 work on Lophiiform strike mechanics established the speed, faster than most cameras can resolve. One frame the fish is there, the next frame it is not. Chaunax pictus is not a red animal that lives in the dark. It is a black ambush weapon that only appears red when you drag it into the light.